when you go to My Lab's math and you come up to this, there it is right there. Usually after the trouble has been called in, there will be a note somewhere on this page or the next page saying that there is a problem. If this goes up, I usually give extensions on the test. Okay. Now, if it goes up the day that the homework is due, I will give a little bit of leniency on the homework. But why do I not give much leniency on the homework? Because you should have been working on it the last 2 or 3 weeks, or the last week, or whatever the case may be. All right. So usually when you see one of these right here, now some of you were doing the test early and it started messing up and you didn't see this. And you're good. You're good to go. I was just, bombarded this weekend with emails. Just breathe and count to 10. And remember, Hubert does not do what the other teachers do. Do I, Miss Polar? You probably spazzed out too, and you went to your brother and said, Hubert's going to give me a 0. Ah! And he probably told you, no, he's not. Just chill. I'm kidding. Did you have any trouble, Miss Polar?
I didn't. I took mine Friday, I think.
Okay.
So
I think it started like Friday night. Miss Gravina, you had some problems, didn't you?
Yeah, but after you fixed it, it worked fine.
Okay. When was that? When did you email me? I can't remember, and I don't want to go look for it. Do you remember when
It was yesterday.
Was it yesterday? Okay.
Yeah.
I couldn't remember. Okay, well, and I think Miss Fry, did you get it? Do you get it okay? Everything okay, Miss Fry?
Yes, sir, I got it.
Okay. Well, when did you do yours and have problems?
Sunday.
Okay. I was thinking it was earlier than that.
But I took mine on Tuesday and it kicked me out, and I emailed you about that. And so I retook it on Wednesday and it was okay.
Oh, well, I probably ignored your email, Mr. King.
Oh.
Did I reply to your email? I couldn't.
No.
Okay, the reason I didn't was I was getting bombarded. Lord have mercy. But yeah, I usually fixed it. So everybody sees. Miss Fry, did your brother get fixed? Did his get fixed?
Yes, sir.
Good. All right. Well, we're all good and y'all not mad at me. All right. So let's go ahead and get started with the new unit, which is chapter 6. Any questions? Anybody got any gripes? I think I saw Mr. Butcher and I think Miss Reed come in. Don't leave yet because, don't leave at the end of class because I need to put y'all's. I'm looking for anybody else that might have came in. I believe Miss Reed and Mr. Butcher came in. I got to do the attendance again.
Yeah,
all right.
I did.
I know. I'm going to get you. Just don't leave. All right. PowerPoint. There we go. Now, you want the good news or the bad news? And the class.
Let's hear the bad news.
Okay. You want what first? The good news or the bad news first, Mr. Butcher?
Let's hear the bad news.
Bad news. Bad news, we are continuing with Unit 3. We're not stopping. Good news is that Unit 3 is the shortest unit. It's also the unit that a lot of you might need to up your grade a little bit, okay? Because there are some people out there that haven't done homework, and as of today, there's 3 of y'all that haven't done the test. So I don't know what's up with that. After like 3 or 4 days, should have it done. But anyway, this is the shortest unit. The first part, chapter 6, is pretty much plug and chug. Chapter 6, 6.1 you got to do a little bit of math. And then 6.2 is plug and chug. And then chapter 7 is finding the area under the curve. I think 7.1 through 7.3, I think. And it's finding area under curve. We're going to spend a majority of our time on this one, okay? So that means 80% of your test is going to come from chapter 7. So you might want to write that down, just like the previous test. I told you that 80% was going to come from chapter 5, and I believe I was correct. There was very few from chapter 4, I think. I can't remember the chapters, but more came from chapter 5 than it should have been from chapter 5 than chapter 4. Same thing here. Most of your problems on the test are going to come from chapter 7. All right. So with that being said, let's go back and look. And what are we going to be dealing with chapter 6? Chapter 6 is all about a probability distribution. What do you mean? Well, a probability distribution looks like this. You remember when we did a frequency distribution back in chapter 1, 2, and 3? Frequency distribution, which I told you was nothing but a table. Y'all remember? And I told you blondes, brunettes, redheads. And 2, 4, 8. Okay, and then I told you that you could have a qualitative and then quantitative. And a quantitative would be, a class and frequency. This is frequency and this is category. And a class would be like 15 to 19, 20 to 24, 25 to 29, 30 to 34, and 2, 4, 6, 1. All right, everybody remember that? Well, now we learned probability in chapter 5. And we're going to take a frequency distribution. We're going to mix it with probability, and we're going to come up with what's called a probability distribution, which is a table. And it looks like this. X is called the event. P of X is the probability of the event. The event will be discrete. Somebody remind me what discrete means. Means you count it, which means whole numbers. Okay, so your event is going to be discrete and it's going to be whole numbers. So like having 0 girls, having 1 girl, having 2 girls, having 3 girls with 3 children. Okay, these are the events. So I'm going to put over here 0 girls, 1 girl, 2 girls, and 3 girls. Another example would be like the World Series. You're talking about games. How many games? Well, 0 games, 1 game, 2 games, 3 games. Or 0 hits, 1 hit, 2 hit, 3 hits. Now, why do I not have any fractions, decimals, or percents over here? Because you can't have 2.5 girls. You can't have 2.5 hits. Okay, you go up to bat, it's like being pregnant. Okay, there ain't no halfway between. You either hit or you don't hit. You're either pregnant or you're not pregnant. You see what I'm saying? There is no half. That one household or 2 households. There is not 2.5 households. You either one household or you're not a household. All right. So when you're talking about these events are always going to be whole numbers, always. And the probability, well, there's 2 tests for probability. And we already know this, but the first test is all the probabilities have to be between what numbers? 0 and 1. You can't have a negative, and you can't have anything above 1. The second test is that the summation of P of X has to equal what? 1. When you add the probabilities up, they have to equal 1. Now, if these 2 tests are not met, then you don't have a problem. You put does not exist, no solution, cannot do this problem, anything but trying to do the problem. So you might have a probability here of 0.1, 0.3, 0.5, and 0.1. And if you add all those up, that's 8, 0.8, 0.9, 1.0. So it checks. All these probabilities are between 0 and 1. So that checks. So this is a probability distribution. Now, they're going to show you some things. Now, this is a test question. The test question will say, is the following a probability distribution? Here's the first one. So I want you to write all 3 of them down because this is going to be a test question. So just write the probability distribution and the reason it's not a probability distribution. And it has the answer down at the bottom. This one is not a probability distribution because if you add up all the probabilities, you don't get 1.0, you get 0.97. Now, there are some books that will say 0.9999 to 1.0001. There are some books that will give you a little bit of a window, but this book, being introductory to probability and statistics, they're going from 0 to 1. So there's no decimals to the 4th or 5th place. And I want somebody to take a calculator and add up all those probabilities and see if you get 0.97.
You do.
Yep. So the events are on the left and the probabilities are on the right. And the first thing you do on a test or a homework problem when you see one of these is you check the right-hand side, and each one of them should be between 0 and 1, which they are, but if you add them up, they're supposed to equal 1, and they don't. So this is an example of a non-complying probability distribution. All right, next one. And of course, this one should, it should stick out like a sore thumb. Why is this one not? Well, you got a negative. You can't have a negative probability. You can't have a number greater than 1. So you don't even need to add these up because it's not going to equal 1 because of that negative. So you can automatically, when you see that negative, or if this was 2.2, you know, something like that. But this is a giveaway right here. So you don't have to write this one down. You can just, you know, put 5 and then negative 0.01, and you can put a big X through it because of the negative 0.01. I'm going to leave that up for a couple more seconds. And the next one is a probability distribution because all the numbers are between 0 and 1. And if you add them all up, they're equal to 1. So I want you to write this one down and make sure you put a big green check beside it because this one is a probability distribution. So on your test or on a standardized test, you will be asked, are the following valid probability distribution? Or does it have the properties of a probability distribution? And you're either going to say yes or no. And the yes will be like this one, where they all equal, all the probabilities added will equal 1. And the probabilities themselves, each one, are between 0 and 1. So that's your first test question out of chapter 6. That's it. All right. So we just went over one test question I would give you. Now, what are they going to ask you for? Well, the next thing they're going to ask you for in chapter 6 is the mean and the standard deviation. The mean and the standard deviation. And the mean of a probability distribution is equal to the summation of each event times the probability of that event. Now, I don't know how in depth your math, your probability and statistics in high school went, but I don't think they went this high. Now, somebody tell me, did they go this high? Have you ever done this before?
I think so. Yeah, it looks familiar.
Looks familiar? Well, I see some people shaking their heads, and of course, some of y'all won't interact and you don't show your videos, so I don't know what the hell you're doing. But most students tell me that they've never seen this before, but they also forget, so I don't know. The standard deviation of a probability distribution is equal to, and we're going to get that right here. Let me go down and find it. There it is. And I don't use the first one, I use the second one. And that is the square root of the summation of x squared times p of x minus mu squared. Okay? And that is the two things that they're going to ask you out of 6.2, out of 6.1. One, they're going to ask you if a probability, if a probability distribution is valid. And then they're going to ask you to find the mean and the standard deviation of a probability distribution. That's the two questions out of 6.1 that they're going to ask you. Now, also, the mean is also called the expected value. Sometimes the book will use the mean as the expected value. And we'll get into that with one of the two of the questions. So this is important. So we need to take our handy dandy pink highlighter for those one or two that do this. And we're going to highlight the mean and the standard deviation. Now, of course, what if I wanted the variance? I would just not take the square root of that number, and that would be the variance. Or I would take this number and raise it to the second power. So 6.1 is not going to be very difficult unless you make it difficult, which some of y'all do that. Not in this class. I mean, just students in general. Some of y'all can break an anvil with a banana. All right, so let's look at it. Let's look at, let me find one. Let's look at this guy right here. And of course, they show you the answer. All right, I'm going to make up one. Ain't no good to show you the answer. Let's go to the handy dandy Excel spreadsheet. Now I'm going to make up a probability distribution for you. Okay, so here is X and P of X. And X is going to be 0, 1, 2, 3, 4, 5. P of X is 0.1, 0.15, 0.26, 0.4, 0.1, and 0.12. I have no idea what the answer is. I'm going to I'll adjust. It's the easiest way to do it. All right, 1.13, so we're going to take this one down to 0.01 and take this down to 0.24. There we go. All right, now I want everybody, you know it's a probability distribution because I just showed you it equals 1. So now I want everybody to do the next line right here, and I want you to multiply. I'll do the first one for you. 0 times 0.1, that's 0. Now you do the rest of them. Do them in your notes so you'll have it, so you'll know how to do this when you ask for the mean and the standard deviation. We're going to do both. So this is going to be X times P of X. I can't take not being centered. It drives me crazy. So 0 times the probability of 0, and copy those down. And then what I do, what does my formula say that I do with X times P of X? What do I do with it? That's a Q, QUE. That means I'm trying to get the class to interact. What do I do with X times P of X after I multiply it? What do I do?
Add.
Thank you. I add them all up. I know that was painful, but I appreciate it. I appreciate the sacrifice. Lord have mercy. People want to start a revolution. They can't even talk in class. All right. Oh, shut up. Shut up, Hubert. Here we go. There's the mean. I want you to do the standard deviation. So I'll go ahead and I'll pull it up again. There is the standard deviation. So go ahead and read it. What does it say? We've got P of X. P of X is, we got that. What do we not have? We've got P of X. We've got the mean. What else do we need? That's another Q.
X squared.
We don't have X squared, so we need to make a column called X squared. We need to make a new column and then do everything the formula asks. So we got to make an X squared column. So go ahead and do that. I'm going to make it right over here. X squared equals this number raised to the second power. And I know, I got a degree in everything. I know what was 0 through 5. I'm going to put them in the Excel spreadsheet so I can actually do the calculation. And we're supposed to take X squared and multiply with the probability of the event. The probability of X, I'm going to just copy that right here. And now I'm going to make a new column called X squared times P of X. And what are we going to do with that? Let's go back to the formula and look. What do we do after we do X squared times P of X? What do we do with it? Add it up. Now we got that number. What are we going to do with that number? Go back to the formula. What do? We got that number right there, 6 point whatever. We're going to subtract what? The average squared. So let's go back. So I'm going to go over here and I'm going to put variance equals, and I'm going to say this guy 6.56 minus parentheses this number raised to the second power. And that is my variance. And what is the standard deviation? What of the variance?
Square root.
Thank you, Mr. King. Thank you. And that should be your answer. So here is what you will be tested on. Now, why do I put the variance in there? I'm just reminding you of the relationship between the variance and the standard deviation. I doubt you will be asked the variance, but I want to remind you of the variance and the standard deviation. Who's got a question? Nobody's going to ask it anyway. I don't know why I'm asking. All right. Let's do a nerd. All right, I want you, let's go ahead and do Let's do another one. I'm going to do 0.2, 0.3, 0.2. Let's see, that's 3 and 4, that's 0.7, 0.15, 0.14, and 0.01. Let me check it right quick to make sure. Yep. All right. Now, I want you to do this by hand. Do that right there, and I want you to do it by hand. And you'll have two probability distributions in your, so I'm going to write it down, and we're going to do it by hand. So 0, 1, 2, 3, 4, 5. That's x. P of x is equal to 0.2, 0.3, 0.2, 0.15, 0.14, 0.01. So we're going to take our handy dandy calculator out, and we're going to do this by hand. So that means I want y'all to work by hand with your calculator. I'm trying to pull my calculator up. If you'll, come it. Things I do for y'all. I'm about ready to quit. All right, there we go. So 0, I'm not going to do that. I'm going to do that in my head. 0 times, let's see, x times p of x. And that's going to be 0.3. 2 times 20 cent is 40 cent. 3 times 15 cent is 0.45 cent. 4 times 14 is going to be what? 56 cent. Somebody help me out there. 0.56. And 5 times a penny is 0.05. 56 cent and 45 cent is what? $1.01. I think that's right. $1.06. $1.46. $1.76. Somebody check my math.
That's right.
Okay. Glad I don't have a calculator. All right. So now you know the mean is there. So let's go over here and let's do x squared. X squared is going to be 0, 1, 4, 9, 16, and 25. And P of X, I'm just going to write it down again. 0.2, 0.3, 0.2, 0.5, 15, 0.14, 0.01. X squared times P of X. 0 times anything is 0. 1 times 0.3 is 0.3. 4 times 20 cent is 80 cent. 9 times 15 cent is going to be $1.35. Y'all check me, please. I don't know about this one because I don't know the easy way to do this one. Let's see. I know what I could do. I could do 10 times 14, that's $1.40. And then 6 times 14 is, hold on, 6 be 84. $1.40 and 84 is 224. Somebody check me.
That's right.
And 0.25. So 224, $2.24, that'd be $2.51, $3.86, $4.46, $4.76. Y'all check me, please.
I got 494.
Okay, I might have messed up. Somebody confirm 494 before we move ahead.
I got that too.
Okay. And some of y'all are maybe saying, why is he changing everything to cents? Because what's the most important thing in our lives besides time?
Money.
Money. And I guarantee you some of y'all cannot be shortchanged at the grocery store. Oh, you took too much money, Well, nobody does change anymore. So anyway, $4.94. So now we're going to do our variance. It's going to be $4.94 minus 1.76 squared. So I'm going to take my handy dandy calculator. 4.94 minus parentheses 1.76 second power. It's hard to do with a mouse. Sorry. Equals. I got 1.84. Somebody check me. I'm going to raise that to the 1/2 power. And 1.36. Did 1.84 check out?
Yes, sir, it did.
All right. I've just told you what 6.1 is going to consist of. 6.1 is going to consist of, is this a probability distribution? Yes or no? And what is the mean and the standard deviation? There's one more question that's in 6.1 that might throw you a curve, and that is this question called about expected value. Expected value is the same thing as the mean, but what they're trying to show you is how the mean is used in the real world. Okay, and that is, there it is. Write this question down and write it word for word. A term life insurance policy. This is a test question, and it's also a standardized test question. Did I tell y'all something good happened to me Friday?
No, what happened?
I had a parent send the president of the college a nice letter. One of my students' parents sent a nice letter to the president saying that their student brought their SAT score up like a lot. They didn't say they did, but I can't remember the numbers. But it was like it was more than 2 digits. I think it was like almost 100 points. They took 2 of my classes. They took a Math 109 and a Math 130, I think. which is algebra and calculus, business algebra and business calculus. And their score, they took their ACT and their SAT again or whatever, and it went up real, and they said something to the effect, I don't know how Hubert does it because his students won't talk to him and stuff like that, but no, she didn't say that. And no reaction whatsoever. Y'all really suck. Except for my 3 Musketeers and Mr. Butcher every once in a while.
But imagine if you did say that, though. That would have been funny.
What?
But imagine if he did say, oh, yeah, but they don't talk in the class, too. You're like,
Yeah,
how do you even know that?
yeah, and he does so well in class, but his class won't talk to him, and they're a bunch of jerks. Yeah, that would have been funny. Mr. King, every time you come to class, I think of my son because you have the bed hair, when you wake up in the morning. And my son, when he was like 3 years or 2 years old, when he learned how to talk, my hair would do the same thing because I have a bunch of hair when I don't have it cut. And Daddy, your hair up high. So every time I see Mr. King, I think of my son saying that. Daddy, your hair up high.
My mom makes fun of me all the time too. I'll walk out of my bedroom. She's like, Jacob, your hair looks great. I'm like, thanks.
Well, enjoy it because I'm going to tell you, everybody that you graduated school with, half of them, 3/4 of them are going to be bald. So hopefully, I'm very thankful for my hair. Very thankful.
Dad went bald in his mid-20s, so not really looking forward to that.
My father, well, see, you take after your mother's side. Because I take after my mother's side, and my sister takes after my father's side. And I think there's some kind of genetic thing there that you take after your mother's side. The son takes after the mother's side a lot. I don't know. But anyway, she's 80-something years old, 81, and she still has black hair. It's a little bit gray, but I'm very, very thankful for my hair. Very thankful. And for a woman, you don't understand what I'm talking about, but guy is the main thing. That's why you see a lot of guys with baseball caps on. All right. Mr. Butcher, I got to pick on you for a little bit. Do you realize that your last name could come from Gangs of New York?
Nope. Didn't know that.
Do you know that William Cutting was known as the Butcher?
Didn't know that either. But with a name like Cutting, it sounds like it'd be true.
Yeah. You have to research your last name and see where it come from. Because the reason I say that is because some people, they just, before you could legally change your name, people would just change their names. If they didn't like their last name, they would just say, I'm going to change my name. And they would just change their name. So you'd have to check that out.
Trying to look into that.
Trying to think, try to drum up some conversation, but that's not going to happen. I would thought somebody besides Mr. Butcher might say, my grandfather changed his name or my aunt changed her name, but hell no, not in this class.
My mom changed all 3 of her names.
You're kidding.
Nope.
I know one of her last names was changed.
Yeah, so when she and my dad got married, whoever was over the marriage forms and all that, all the legal stuff, forced her to keep her maiden name. It wasn't her choice. It was some law that was trying to be passed at the time. And so she had to keep her maiden name. And then her first name is Shari, but it's spelled, or it's originally Sharina, but she didn't go by Sharina. And everybody would call her Charlie. So she changed the spelling of her first name. And then she was like, well, while I'm at it, I might as well change my middle name too, because I don't really like it. So,
That's funny. That's funny.
yep.
Now, what's that first name? Where is that from?
I have no idea.
That's interesting.
Yeah, and she doesn't know either.
I
don't
wish
think
I
Mom
could
knows
change my name, because I'm gonna be honest with you. Hubert sucks. I mean, that's a real terrible name. I don't know. My father named me after his favorite uncle. Thanks, Dad.
I think it's
You know.
memorable. Hubert.
Yeah, and nobody calls me Hubert. Everybody calls me Herbert. Now, I want you to look at my name. My name does not have an R on the first syllable. It is a conspiracy. All right. But yeah, before you could legally change your name, one of my ancestors, they didn't like their name, so they just changed it. They didn't go through any legal process. They just changed it. There was a little bit of shaming going on. It was a woman, and I think she got pregnant before she was supposed to, or whatever, before she got married or whatever. So she just changed her name. Oh, well, you find out stuff like that when you do genealogy. I'll tell y'all a little secret. If you think your ancestors were angels, they wasn't. You think you have soap operas and drama today? No. There was drama, and there was all kinds of things going on back in the 17 and 1800s, let me tell you. No, that's just Hubert's family. Yeah, just my family. Yeah, that woman that I was telling you about that changed her name, her sister, before she changed her name, she had a sister who was married to the guy, and she changed her son's last name and her last name to the middle name of the guy that married to his sister. So you figure that out. You've come to the conclusion that he stepped out with the sisters. 0.99791.00209 and negative 249,470. Now, the reason I'm just writing these numbers down is I'm going to explain where these numbers come from. All right, first of all, this is from the view of the insurance company. From the view of the insurance company. Is an insurance company, is it a business? Yes or no? Okay, I'm going to say it again, and hopefully somebody will say yes or no. Is the insurance company a business?
Yes.
Yeah.
So that means negative means a loss, and positive means a what?
A gain.
A gain or a profit. Okay. Now we're looking at this from the eyes of the insurance company. So what are the two events? Well, you either live or you die. That's our events in this problem. You live or you die. I'm sorry if the negative dying, I'm sorry if that offends you, but that is the opposite of being alive. There is no half dead. There is no half alive. You either die dead or you alive, one of the two. Again, we go back to the pregnancy example. You either pregnant or you're not pregnant. Now, a lot of people say they're offended because I use pregnancy. Well, I'm sorry, okay? But that's the two black and whites in life. You either dead or alive, you either pregnant or you're not pregnant. Okay? I'm sorry. If that offends you, I'm sorry. I don't know what else to use. All right. So you either alive or you dead. So if you're alive, we're going to put alive. If you're alive, then that means that the insurance company gets how much money? They get that payment of $530. And this probability means that you're alive. So the event is that you survived the year and you gave the insurance company $530 payment. And this is the probability that you're going to be alive. Being alive, probability of being alive. Now, being alive is not, this right here, this word right here means nothing as far as money. So you can't put being alive right here. You can't put the words being alive right here because this is a what? This is a business. Businesses only work with numbers. So instead of putting being alive in this column for the event, you put the number amount associated with being alive. The number amount for the insurance company is a gain of $530 per your payment. And the probability that you're going to be alive by the end of the year is 0.99791. Now, what is the opposite? What is the complement of being alive? Being dead. So if survivability probability is 0.99791, subtract that from 1 and you get the complement. Have you ever tried to write and watch your writing and try to write without looking at your hand? It's hard to do. Very hard. A lot of people think I'm crazy. We'll try to rub your belly clockwise and rub your head counterclockwise. See if you can do that. All right. I'm sorry. I shouldn't have done that. Some of y'all are going to get confused. Okay. So that's the complement. Some of y'all are trying it right now. All right. No, not this group. You ain't going to try it. So what is the complement of being alive to the insurance company? You got to pay out what? A claim of $249,470. Why is that such an odd amount? Why didn't they just give you $250,000? They did give you $250,000, but in the eyes of the insurance company, what did they actually give you? They actually gave you this because they've got $530 of your money. Does everybody see that? They give you a check for $250,000. They don't give you a check because you did. All right. They give your beneficiary. They give you they give your beneficiary $250,000. But that's not what they see in their eyes. What they see in their eyes is they gave you a check for $249,470 because they got $530 of your money. Okay? So that's going to be 530 times 0.99791 plus negative 249,470 times 0.00209. And basically, you're finding the mean, which is also called the expected value. And that comes out to be what? $7 and what was it? $7.50. Now let's talk about the answer. Somebody tell me what the answer means. Well, first of all, is it positive or negative?
Positive.
Okay, so we're going to highlight it green because it's positive. Okay, positive means a gain for the insurance company, which means a profit. What if you come out with a negative? Then that means the insurance company is losing money and losing profit, so it's got to make an adjustment to make that negative a positive. So that's what the $7.50, you can't look at it like, well, God Almighty, you telling me that the insurance company only made $7.50? That's not the way to look at it. The way to look at this is from a business perspective. If this is positive, that means the insurance company is doing okay. The bigger the number, the better, but that means that they're doing okay. If it was a negative $7.50, then the insurance company would say to themselves, we need to make adjustments because we're losing money. It doesn't matter. Well, it does matter how big it is, but you know, the negative and the positive is the main reason, you know, to do this expected value. All right, so that's the other type question you'll have. Question, great, complaint. Nobody's going to talk. Okay. All right, so let's look at 6.2. Hubert, you're moving very fast. It's not that big a deal because 6.2 is very simple. I'm going to go ahead and show you the actual. I'm trying to find where it begins. Okay, slide 25. NPX. Where is my, there we go. All right. Now 6.2, you're going to be doing plugging and chugging. Now, the first formula that we're going to go over in 6.2 is very complicated. So I'm just going to show you how to do it in a calculator by using binomial PDF and binomial CDF, okay, with the calculator. All right. The next question you're going to have is the mean.
Hello.
Hello?
Yes, ma'am. It's okay.
Evidently, she got a phone call. All right. Mean is equal to NP, or am I supposed to have a conniption? I guess I'm supposed to have a conniption, ain't I? NP, and I think the standard deviation, or the variance, is equal to NPQ, and the standard deviation is equal to the square root of NPQ.
What happened?
Okay? Now, in the plug and chug with the first question, you're going to be focusing on NPX. All right, now I want you to write that down because that's 6.2 in a nutshell.
Yeah, I'll do it as soon as my class is over. It'll probably be about like 9.
There. I don't think she's aware that her microphone is on. All right. So make sure you write down everything right here, and then we'll go back to the notes and we'll actually look at a problem. Has everybody got it? Well, I know 2 or 3 people have got it because I can see them and they're not writing, but of course, the rest of y'all I can't see because you won't do the video and you don't talk. So trying to let y'all know how how, difficult it is to teach with no interaction. So.
I mean, I got it down. So
Thank you, Mr. Butcher. Thank you for helping me out there. Thank you. And the rest of the class says absolutely nothing. Y'all are pathetic. And then you're gonna wonder why you got a janitor's closet as an office. You're gonna wonder why. Just remember what I told you. All right, so let's go back up and let's look at what they're talking about. 25, there we go. Now we're still working with probability distributions, and go ahead and write this one down. Criteria for a binomial probability experiment. Write those 4 things down. The experiment is performed a fixed number of trials. In other words, you flip a coin 50 times. The trials are independent. This means that the outcome of one will not affect the outcome of the other. Flipping a coin. If I get tails when I flip a coin, that doesn't affect the next time that I flip a coin. Now, if I flip a coin up in the air and it gets struck by lightning, then yeah, then that's affected. But if I flip a coin or roll a die or pick a card out of a deck of cards, it's not going to be affected as long as I put the card back in to the deck before I draw again. Those are not, they're not affected. For each trial, there are 2 mutually exclusive outcomes. Tails, heads. A certain number, not a certain number on a die. A black card or a red card. There has to be 2 outcomes. And the probability of success is fixed for each trial of the experiment. In other words, there's no other way that you're going to get heads or tails by not flipping. You flip a coin, you're going to get one of the other. All right, so that's what we're dealing with here. Now we're also dealing with this type of question. I'm going to just give you an example. Johnny, I'll just make it, I don't know, that's a girl's, I don't know, anyway. Jenny, Johnny, whatever you want to call it, flipped a coin 500 times. Out of 500, comma, 200 came up tails. What is the probability of tails if you flip the coin 200 more times? Let's just say 20 times. I don't want to do 200. Let's just say 20. All right, so Johnny flipped a coin 500 times. Out of the 500, 200 came up tails. So that's probability right there of tails is equal to 200 over 300. And that's going to be 2/3, which is 0.67. Everybody with me? And we need to highlight that because we just calculated that from what's given. So what is the probability of flipping? What is the probability of tails if you flip the coin 20 more times what is the probability that those 20 flips, out of the 20 flips, will come up tails? So n is equal to 500. P is equal to 0.67. And x is equal to 20. Okay, now that's what we're going to be doing the first part of 6.2. You're going to read a question, and you got to figure out what is n, what is p, and what is x. And the reason that is because those are the three things you type in to your binomial PDF. N, p, and x. And of course, this is fixed number of trials, 500 is fixed number of trials. Tails or heads, you either have two and one doesn't affect the other. And if you flip tails, that's not going to affect whether you get heads on the next one. So it does fit. All right. So this is the type question you're going to see in the examples. So let's go ahead and find one. You also need to remember, well, let's give you an example of what's not a binomial experiment. This one is a binomial experiment. A player rolls a pair of die 10 times. The number x of sevens rolled is recorded. That's a binomial experiment because a die is not affected by anything. You roll a die across the table, it's fair, unless you've got some kind of magnet or some kind of weight inside of it. It's fair. All right. If you roll the die 10 times, that's a fixed number of times. Sevens is either going to come up 7 or not 7. That's two different answers. 7 and not 7. And nothing is affecting the die. So that is a binomial experiment. Okay. The 11 largest airlines has a on-time percentage of 0.84. That's P. Okay. In 2001, according to the Air Travel Consumer Report, in order to assess reasons for delays, an official with the FFA randomly selects flights until she finds 10 that are not on time. That is X. P and X. What are we missing? We're missing N. We're missing N. N always has to be the biggest what? Biggest number. We've got X. How do you know that's X? Because the way the question is worded, there needs to be a P somewhere up in here. Out of 500 of the 11 largest airlines flights, then it would be a binomial experiment. Okay? You've only got P and you've got X. You don't have an N because N is always your largest number. All right. God, it's rough teaching classes and nobody talking. In a class of 30 students, 55 are female, the instructor randomly selects 4 students. The trials are not independent because you can't replace how many. Okay, if I pick one child, how many is left in the class?
29.
Okay, so it's not independent. It's without replacement. Without replacement, it is not independent. You have to be independent. So when you do an experiment, the next experiment is not mathematically challenged. As soon as you pick one student or 4 students, you got 26 left. You pick 4 students, you got 22 left. You pick 4 students, you got 18 left. It's not independent. I'm not going to go through this. Okay, I'm going to go through this, but I'm not going to go through the airlines. I'm going to show you this. This is an explanation of how you get the probability distribution with a binomial probability. The first section, 6.1, was on probability distribution. Okay, let me explain this to you. Six 6.1, we talked about a probability distribution. And you had an event here, and you had the probability of an event here. And 0, 1, 2, 3, and 0.1, 0.2, 0.3, and let's see, that's 0.4. Okay, that's the probability distribution. With a binomial distribution, I'm showing you actually how you get these numbers right here. Let's say 0, 1, 2, 3. And let's say that these are girls born. Okay, girls. 0 girls, 1 girl, 2 girls, and 3 girls. So we're going to take this over to the next page. And I'm going to put the event X and Y, or P of X, sorry. And I'm going to put 0 girls, 1 girl, 2 girls, 3 girls. And the probability of girls is usually 0.52. They're going to give you that. All right. When you're doing a binomial distribution, they're going to give you a P, and that's 0.52. Therefore, what is the probability of boys? Somebody tell me the probability of boys.
0.48.
Good job. Somebody's actually listening this semester. And I'm going to highlight this in pink, kind of give it a little bit of a color difference, because up here it's going to pay off to have a color difference. All right. So now I hope nobody's offended that I highlighted this pink and this blue. I hope you're not offended, but if you are, I'm sorry. Okay, so what do I do? Well, somebody tell me what 0 means. What does it mean in our application here? 0 means what?
Probability of 0 girls.
Which means probability of what?
X.
No, 3
no.
what? If you have no girls, that means you have what?
Oh, a boy.
Not one boy, but what?
Or all boys, sorry.
All boys.
Yeah.
So that's going to be 0.48 times 0.48 times 0.48, or 0.48 to the third power. Okay? Now, somebody tell me what 1 girl means.
Two boys.
Means you have 2 boys. So that could be 0.52. Hold on. Let me get the pink. 0.52 times 0.48 times 0.48. Well, we got 3 different ways. Let's see, we could have a girl in the middle. So that's going to be, let's see how I'm going to do this. I'm going to put a black bracket here and there. And then I'm going to say plus bracket bracket, and that's going to be 0.48, and 0.48 times what? 0.52, and then plus, see the things I do for y'all, plus 0.48 times 0.48 times 0.52. Now there's an easier way to write this. Can somebody tell me what the easy way is? Three times 0.52 times 0.48 squared. So I'm going to write that out to the right here if I can. Equals 3 times 0.52 times 0.48 squared. Okay, what does 2 mean? That means I have not one girl, but what? 2 girls, Hubert. Thank you, class. And that's going to be 0.48 right here. Somebody tell me what this looks like simplified. 3 times what?
0.48 times
0.48
0.5 squared.
times 0.52 squared.
Hey, Hubert.
Yes.
It's 9:27.
Oh, I'm sorry.
It's
Appreciate
okay. I
it.
just
I
wanna let you
appreciate
know.
who said that.
I guess Miss Johnson.
Thank you. Thank you for the interaction. Y'all notice what happens when somebody communicates? We get to end class. Thank you for communicating. I appreciate that. So I'm going to cut the recorder off and we're going to stop for today. And I'm going to check the